Hello everybody and welcome back to Crash Course. My name is Brendan and today we're going to be talking about compound interest. Now, before we get into compound interest, we should recap on what simple interest is. In our last video, we talked about how simple interest is an additional amount of money that you add to an original price over time. Now, in order to calculate that most of the time, all you need is a formula. I is equal to P times R times T. I is your interest, P is your principal or original payment, R is your rate, which is your percent of increase, and T is your time. An example of this would be if you have a $100 loan that you're paying off over 10 years at a 2% yearly increase. So if it's a standard amount of interest, then it's going to be I is equal to 100 times 0.02, which is your 2%, times 10, which altogether will mean that you're paying a total of $120. So with that in mind, the question then is, what is compound interest? So looking at compound interest, it's very similar to simple interest, with the difference being that compound interest is finding interest and adding it exponentially, or in other words, putting it on top of your previous interest and the total price. So instead of it just being $100 at 2% for 10 years, where you just get an extra $20, you take that 2% and every year you add it to your previous price. So exponentially, it starts going up. As you can see here, it's sort of like adding it to itself over and over and over again. But it's really just adding the interest for each time that you're going to be paying. So how do we actually do it? If we take things from a historically old-fashioned style, we could always just do it 1 year at a time and try and figure it out. To set it up, we have to first identify the pieces that we're working with. So of course, our primary payment is 100, our rate is 2%, and our time is 10 for 10 years. Now, we're not going to be focusing on the 10 in the same way. We're going to be taking it a step at a time. So in solving it, we of course start with our main things being the principal and the interest rate, and we're going to add the interest to the principal for each year that we're going to be adding on. So for example, for year 1, we would have 100, we'd multiply it by 0.2, that gives us 2. We add that to our $100, and at the end of year 1, we have $102. Now the next year, instead of starting with 100 again, we start with 102. So it's stacking on to the next year. So now we multiply 102 times 0.02, and that gives us $2.04 to add on again, giving us $104.04. And the next year, again, we keep that principal amount and we add to it. This continuously happens over and over again until finally we wind up with this long string of numbers that rounds up to roughly $119.51. That's the way that it would work if I was doing my math correctly. Unfortunately, I don't think I was in this one, but that is the general principle of how you would have originally done compound interest. A simpler way to do it is to use the actual formula for it. And the formula is usually just called the compound interest formula, or can be sometimes called the periodic compounding formula. Now, the periodic compounding formula, or compound interest formula, looks very similar to simple interest formula. There's a few key differences in it that you'll notice right out the gate, because it looks a little bit bigger and a little bit more intimidating. Initially, it's A is equal to P times 1 plus R over N to the power of N times T. That seems like a really big, complex scenario, but it's really just as simple as the simple interest one. Let me show you what I mean. Initially, for your simple interest, you have I on one side of the equation instead of A. But the A is actually just meaning the total amount that you're going to be paying. So that's the amount including your original price and the interest that's accrued over the years. Your P still stands for your principal, or your original price. Your R is still your rate of interest, which is the percentage that's converted to a decimal. The T still stands for the total time, which is usually done in years, but can be done in other ways depending on the amount of time for the loaning and the interest. The thing that really makes it different is N, and n is the number of payments that you're going to make per year. Now, that could be one time, that could be two times, or it could be 12 times, depending on the situation. Some companies will charge you by monthly invest instead of just once a year. Something else to note with that is the fact that the 1 really just stands for 100% of your principal payment. The reason for that is that when you are adding all of this stuff up, it's considering the fact that you are taking the original payment and the percentage over how many times you're paying it. So it's really just saying 100 and the extra percentage of your initial price multiplied by the exponential amount of how many payments you're making in a year. So let's take a look at that example again. So if we're doing $100 and we're paying 2%, but it's compounded interest over 10 years, then let's start off with our usual step. Step 1, let's identify what we have. We know that our P is 100, we know that our R is 0.02 because we converted 2%, and we know that our T is 10. Now the only difference is, instead of it being the simple interest where it's just those three, we're going to add 1 with an N. The reason why we're doing it with 1 is because it's not specified that it's adding up more than once a year. With that in mind, we're going to then plug our numbers into our equation. So our equation should be A is equal to 100 times 1 plus 0.02 over 1 to the power of 1 times 10. So now we have everything lined up in the proper place. So now we're going to solve using order of operations, or as some people like to call it, PEMDAS. So the first step is, of course, to solve in the parentheses with our division problem. So 0.02 divided by 1 is going to be 0.02 because anything multiplied or divided by 1 is going to be itself. The next step is adding the 1 to our 0.02, giving us 1.02. After that, we go out to our exponents because we've solved everything inside the parenthesis. Our exponents are 1 times 10, which is going to be 10 because, again, anything times or divided by 1 is itself. So now we have 1.02 to the power of 10. That's going to give us this long string of numbers, 1.218994419994757130024. We can simplify that down if we're doing it by hand. If you're doing it with a calculator, it's best to keep all of it in its proper string. Now, once we get that number, the only thing left to do is to multiply it by our principal, which is 100. When we do that, we're left with 121.899441999, etc., etc., or, since we're simplifying it down because it's going to be money-based and it's just going to be 2 decimals space away, it's going to be $121.90. Again, this is how it's done if it's done properly, and you can see that the money is increasing just a little bit in this situation. Now, what was to happen if we were to be doing this instead of a yearly basis, a monthly basis? If we're doing it based on a compounding monthly interest over the 10 years instead of just once a year, then our numbers start off the same, with 100, 2% being 0.02, 10, and then our n is actually going to be 12 because it's happening once every month, which is 12 times in a year. So our equation then is going to be A is equal to 100 times 1 plus 0.02 over 12 to the power of 12 times 10. So from there, we go through the same steps. It's just that we're going to be having a little bit more complication because of 12 instead of 1. So our numbers are going to get a little bit longer. I briefed a few of them, although I still crunch them in full length in the calculator. So you can see 0.02 divided by 12 becomes this long string of continuously running sixes, so I simplified it down to 0.00167. Adding the 1 to that gives us 1.00167. Multiplying 10 by 12 for our power gives us 120. So 1.00167 to the power of 120 gives us this long number, 1.2211, etc., etc. Multiplying that by 100 gives us roughly $122.17. So again, it's adding up, but it's not necessarily adding up in a way that's going to be confusing. Now, if we take things a step further, we can take a look at how we use these things in our standard life. For example, let's say that you're deciding that you're going to buy a new car. So you go to your nearest dealership to look around and you find your dream car. It's only $65,000 and it's only at 1.4% annual interest rate. So before you buy the car, the seller asks you if you intend to pay the car over the course of 5, 10, or 20 years. So which is the best option if you can only pay $650 a month? If we take the time to look, and we take the time to break things down the way that we did before, here's what we're going to wind up with. Our principal is going to be $65,000. Our rate is 1.4%, which converts to 0.014. And then our time will vary from 5 to 10 to 20. We're going to do this equation 3 different times to make sure that we double check everything for finding out what is going to work best for us. And then, of course, since they haven't specified anything except the fact that it's annual, then our n is going to be 1. So our equation is going to be set up the same as the other one, with the exception of the fact that we're going to be doing it 3 times over, once with 5, once with 10, and once with 20. After that, in order to figure out how much we're doing each month, we're going to divide them, meaning our totals, by the months required to pay it off. So for our 5-year one, we're going to be dividing it by 60, our 10-year is going to be 120, and our 20-year is going to be 240. That's in order to figure out our price payment per month to pay everything off on time. If we do our numbering right, and if we crunch the numbers in the proper manner, we should wind up with the following answers. We should wind up with about $69,679 or $1,161 per month for 5 years, $74,695 or $622 per month for 10 years, and then $85,836 or $357 per month for 20 years. Looking at this, you can see that there is a significant difference in how long interest can accrue. In just a few small years, you go from paying a couple thousand more to almost double in some places. So the important thing is to keep in mind which one is most valuable and which one is best working for you to make sure that you're not going overboard. In this case, that's the 10-year plan. 10 years gets you at just shy of your $650 a month, but make sure that you're not paying too much to get your car done. All right, everybody, that's all that I have this time around. Thank you for watching. If you learned something, I hope that you'll smash the like button, and I hope that you will stay tuned for further lessons. Thank you.